Hey calculus kids, welcome to week 5 Monday, our virtual day again. I hope you guys had a great weekend. Go ahead and pause the video for the 3 warm-up questions. For question number 3, it asks you for the 3 different types of discontinuities, which we talked about last week. The first one is discontinuous because it is undefined at C. So assuming that this right here is C, what's happening is as x approach C on the left side is defined, as x approach C from the right side, it is also defined because it's consistent, but then when x equals C, it is an empty set, so it does not exist because all 3 conditions have to be met with the same y value. The second one is limit does not exist as C. As you approach x to 2, let's say for example on the right side, it is at 3. As you approach it on the right side, it is at 5. But when x is equal to 2, the y value is at 5. So unfortunately, as x approaches 2 on the left side, comes inconsistent with the right, and also when x is equal to 2. The last one is the limit exists as C, but is not equal to f of C. So as x approaches to the left, it is, let's say it is at 3. As x approaches this point on the right side, it is also at 3. But then when x is equal to this point, and let's maybe call this point A, it is all the way up here, and that is at 5. So the limit exists as C, but it's not equal to f of C. Last class, when I saw you guys on Friday online, you guys had the guided notes with some of the questions from the textbook because it's another way of giving you guys more resources and also exposure to the different types and levels of difficulty when it comes to certain questions that might be appearing on the AP exam. You should have filled this part out. I told you if you had any time difficulty, you can type this tiny URL in, and it has a video that goes over these questions step by step. But I certainly encourage you guys to go ahead and try it on your own first. And essentially, it's just a summary of everything that we've learned up to this point. I believe that going over one skill set, such as discontinuity of limits, is important that we kind of go over it on 2 different days. The first day is to kind of give you guys the exposure of what the material is, and then the second day is when it finally sinks into your mind, and then you're able to practice it at a higher level or a higher depth of knowledge level. So hopefully you filled out these 2 pages. There was one question here that's on a limit that we have not attempted to talk about. And if you take a look at this right here, how would I go ahead and make this limit undefined? It is when x is going to equal to 3. So I'm going to approach this limit from 3. I can go ahead and create a table of content or a table of limits. So let's say if I approach x to 3 on the left side, on the left side of 3, and if this is a number line, here's my 3, I will have 2 and 1 on the left side. So let's use 0, 1, and 2. And then as x approaches 3 on the right side, I will have the numbers on the right side because everything here is on the left. I will have everything here on the right. And that will be 4, 5, and 6. So let's go ahead and fill out my table. So if x equals 0, if I plug it into the absolute value, I will have a -3 absolute value, which is going to make it a +3. Then 0 minus 3 is going to be a -3. +3 divided by -3 is a -1. Let's try with 1. 1 minus 3 is a -2, but with the absolute value, it's going to give me a +2. 1 minus 3 is a -2, -1. So far it's consistent. Same thing with 2. 2 minus 3 is a -1. 2 minus 3, well, that's going to be a positive with the absolute value. -1, so it's a -1. So I can say that as x approaches 3 from the left side, f of 3 is equal to -1. Or actually, I could say y is equal to -1 is what I should do. So let's go ahead and erase that. Okay, then let's take a look as x approaches 3 from the right side. So if I plug in the 4, I will have a 1, which is a positive 1. Same thing with a 5. 5 minus 3 is going to give me a 2. 2 minus 3 is a 2, positive 1. And I can just, assume that that's going to give me a positive 1 as well. So equals positive 1. Oops, positive 1. And as you can tell right here, because of the left and right side, it is inconsistent. So you can say that this limit does not exist. Here are the answers to the other questions that you guys have gone over. And we will go over that in a second as well to show you the answers. The next thing I had you guys do is, what did a college freshman who failed his first calculus test have in common with a college freshman who was fined for driving 60 miles per hour in 30 mile per hour zone? So here are the answers for these questions. Neither students knew his limits. Haha. Nerdy math joke. I do want to go over 2 of the questions with you guys. The first one being this one here, as x approaches 1. If you use direct substitution, obviously you're going to have a 0, which does not exist or undefined. So there has to be other ways we have to use to be able to find the limit for this. And the first strategy I taught you guys was using the conjugate. So instead of writing a 1 minus square root of x, we're going to have this multiplied by 1 plus square root of x in the numerator and the denominator, because you can always multiply by 1. So then once I have this, I'm going to go ahead and FOIL it. And if I do FOIL, 1 times 1 is 1. That's the first. Outer inner is going to cancel because there's a minus and a plus, and they're the same square root of x's. And then the last is going to be a negative. Square root of x times square root of x is just going to be 1 minus x. And guess what? You actually did not have to FOIL the top, the numerator, because you can cancel the 1 minus x directly with the numerator. So that part cancels, and you're left with a limit as x approaches 1, 1 plus the square root of 1. So let's go ahead and do direct substitution. Yeah, I already did it. And so your answer here is going to be 2. The second type of questions that will result in undefined strategy is you have to combine 2 fractions together. I know direct substitution is going to result in a 0 in the denominator. So my first goal is to maybe combine the numerators, 2 fractions. So I know my common denominator is going to be a 2x. So I'm going to have the first fraction, 1 over x, multiplied by a 2. And the second fraction, which is 1 over 2, to be multiplied by an x. Okay, so then I have 2 minus x over 2x. And then if you take a look at the denominator right here, it is divided by x minus 2. But if I were to multiply instead, I could revert it to 1 over x minus 2. And right now I can see that these two are very similar to each other. However, if I were to go ahead and factor out a -1 from the numerator here, I will get a -2 plus x, which in turn, if I use the commutative property, is the same thing as -1 times x minus 2. So I can now go ahead and cancel these 2 terms. And then I'm left with a -1, so don't forget the -1 on top, over 2x. Now we're going to apply the limit. X approaches a 2, which is a -1 over 4. And that's your answer. Here are my notes from Friday on limits. Make sure you guys read them. And here are the answers to the textbook guided note problems with a video. And you guys can go ahead and take a look at them. Some of them I did go over in class with you guys on Friday. Pause the video to fill out the notes. All right, so today what we're going to talk about is going to be rules and practices to find the vertical asymptote and rules and practices to find a horizontal asymptote. I do have a quiz that has 21 questions on vertical and horizontal asymptotes. I also have a video practice problem as limit approaches infinity. You can go ahead and copy down the examples on a separate piece of paper as well. And I also have some additional textbook problems that I'm going to have you guys go ahead and practice in class. Normally, if you're in class, we will be doing a foldable with 4 different folds. First fold is how to find the vertical asymptote. Then we're going to go over examples on finding that vertical asymptote. Third flap will be steps of finding the horizontal asymptote. And then the fourth flap will be examples on finding the vertical asymptote. But unfortunately, I don't see you guys in class, so we'll just go ahead and do this informally. So what are asymptotes? Asymptotes are boundary lines where your graph cannot cross them and it does not give you a value. So what do they look like? They're generally represented by dashed lines. A lot of times, if you have a function like f of x equals p of x over q of x, to find the vertical asymptote, it's to take the denominator and set it equal to 0, because you essentially cannot have a 0 in the denominator, or else it's going to result in undefined. And a lot of times on a graph, those little dashed lines represent where the graph is undefined. So what we're doing is we're kind of working backwards. We're looking at the graph going, okay, well, these are the points where this graph is undefined. So how can I specifically make this example undefined? Well, one way is if you have a 0 in the denominator. So to work backwards, you're going to set your denominator specifically equal to 0, solve for x, and that x value is where your graph is going to result with an undefined section. So that's what we're going to be doing. Okay, so if p of x and q of x have no common factors, so first things first, you will have to factor anything that's possible to factor, cancel anything that cancels out from the numerator and denominator. Then once you do that, you set the denominator to 0, solve, and figure out what x is. If you're curious what asymptote mean, it comes from the Greek root, which means not meet. So if you take a look over here at this example, here you have 2x over x squared minus 1. So if I were to find the vertical asymptote, I would take this, set equal to 0, factor it. What times what gives me a -1? When I add it together, it gives me a 0. It will be a -1 and a +1. Solve for x, +1, -1. If I were to graph this problem on a TI-84 calculators or even on Desmos, this is what the graph will look like. And as you can see, these dashed lines where the graph does not meet are the vertical asymptote, vertical because you're going up and down. And then also x equals +1, -1, which is right here. And that shows you where the vertical asymptote is. So let's take a look at this graph. 1 over x minus 2 plus 4. So if I were to set the denominator of this equal to 0, my vertical asymptote will be x equals 2. So here's x equals 2. Here is your vertical asymptote. As you can see from the blue graph, they do not touch the line where x is equal to 2. Okay, let's go ahead and take a look at this one here. So find the vertical asymptote of this example. Remember I said first thing we'll do is we're going to factor if it's possible. So let's go ahead and factor the numerator and the denominator. With the numerator, you want to ask yourself, what times what gives you a -9, but when you add those two numbers together, it gives you a +4. So going back to Algebra 1, if you think about it, I can think about maybe 3 times 3, 9 times 1, but neither of those numbers of 3s or 9s will give me a positive 4. So right now, I know that I cannot factor the numerator without using quadratic equation, which will give me a bunch of decimals. So I'm just going to keep it as is. But the denominator, and I can't cancel anything, so that's kind of what it's confirming. So in the denominator, I'm going to set it equal to 0. I'm going to factor it. So what times what for the denominator equals the positive 21. And then the same two numbers added together gives me a 10. First thing that comes to mind is 21 and 1, or 7 and 3. And obviously in this case, it would be 7 and 3. So x plus 7, x plus 3. Now when I solve for this, x equals negative 7, x equals negative 3. And if you take a look at the graph here, it doesn't deconfirm it because here is x equals negative 7 and x equals positive 3. You can go ahead and graph this on decimals for your TI-84 calculators to reconfirm this, and you can see that it's going to verify that the graph that's right here highlighted in yellow is not going to be touching anywhere near x equals negative 7 or 3 for the vertical asymptote. Okay, so here I have a few examples of the vertical asymptote that you can now practice on your own. There are 5 examples. You can go ahead and pause this video to find all of the vertical asymptotes. Okay, now here are the answers to the 5 examples that you just practiced. I want to go ahead and go over number 2 right here. Because with the last example, we were not able to factor out the numerator. But with this one, you would be able to, because if you take a look at x squared plus 3x minus 10, you will be able to factor the numerator out to x minus 5, x plus 2. In the denominator, you can factor x minus 2, x plus 2. And if you look at this right here, you can cancel the 2x minus or x plus 2's, which will result with just an x minus 2 set equal to 0. My vertical asymptote will be x equals 2. And if you look at that right here, it is indeed going to be, I think that's a positive, sorry. X plus 2. Okay, now let's go over to finding the horizontal asymptote. Here are the rules and steps. Horizontal asymptote is going to be horizontal going from left to right. So when you're looking at the horizontal asymptote, it is essentially looking at the degrees of p of x, which is the numerator, and q of x. And there are 3 different rules. Let's go over them. If the degree of the numerator is smaller than the degree of the denominator, then the horizontal asymptote is y equals 0. Like for example, x squared over x cubed, the horizontal asymptote is y equals 0. Second rule is if the degree of the p of x, which is the numerator, is equal to the degree of q of x, then you're going to disregard the degrees and then simply look at the coefficients. So for example, 6x cubed divided by 2x cubed, same degrees, so ignore that and just focus on the leading coefficient. So 6 divided by 2 is the horizontal asymptote is y equals 3. Last rule, if the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. So here are some examples, 5 examples for you guys to practice finding the horizontal asymptote. You can also practice this by finding the vertical asymptote as well. I'll give you guys the answer for both, so pause the video. And here are the answers for the horizontal asymptote and the vertical asymptote for all 5 questions. This does become a little bit tricky if you have something like this, for example, and in which case you're like, well, what is my degree? Well, you're going to go back to Algebra 2, where remember you have the root versus functions or powers. So something like this, your power is a 1. Your root is a 2. So you could rewrite this as x 1 over 2 in a fraction from radical form to exponential form. Remember that radical form back in Algebra 2 honors? So then here this will be x 1 over 2 over x. Similarly, another one that you can have is something that looks like this. So your power is a 2, but your root is also a 2. So what does that equal then? It just equals x. So just be on the lookout for examples like this. All right, I think that's pretty much it for today. Um, I will highly recommend that you go ahead and practice with some of the questions that's on your guided notes. In addition to that, I do have some additional examples right here for you guys to practice with. So take a look at these examples of 1 to 10. Do read the notes that I have written up for you guys on specifically vertical asymptotes. And remember, with the vertical asymptotes, it's as if the limit approaching infinity, because as x is approaching infinity, it's telling you that your graph is either going up or it's going down. And it is the same thing as finding the horizontal asymptote. So using those 3 rules, make sure you go over these examples that I have shown you guys. And that is it. I hope you guys have a wonderful Monday, and I'll see you guys on Tuesday.